All right, in this video, we're going to look at actually verifying some other trig identities. But first, in the last video, we talked about the Pythagorean identities, and we derived where each of them come from. So our first one, cosine squared plus sine squared, based on a little bit of algebraic manipulation here, we can get some alternate forms for each of these Pythagorean identities. So for instance, if we subtract sine squared from both sides, we get cosine squared of an angle is 1 minus sine squared. And 1 minus sine squared we can factor as a difference of squares. 1 plus sine times 1 minus sine for cosine squared. So this is just the factoring of 1 minus sine squared as a difference of squares. Likewise, if we subtract cosine squared from both sides, we get sine squared is 1 minus cosine squared. And just like we factored 1 minus sine squared as a difference of squares, we can also factor 1 minus cosine squared as a difference of squares. So sine squared could also be 1 plus cosine times 1 minus cosine. For 1 plus tangent squared equals secant squared, if we subtract 1 from both sides, we'll get tangent squared equals secant squared minus 1. And again, we can factor secant squared minus 1 as secant plus 1 times secant minus 1. If we subtract tangent squared from both sides, we get 1 is equal to secant squared minus tangent squared. So if we factor secant squared minus tangent squared, it's secant plus tangent times secant minus tangent. For our third Pythagorean identity, 1 plus cotangent squared equals cosecant squared, we could start by subtracting cotangent squared from both sides, and we'll get 1 equals cosecant squared minus cotangent squared, and then just factoring it as a difference of squares. We could also subtract the 1 from both sides. Oh, I apologize. This should read cosecant squared theta. There's a bit of a typo there. I apologize for that. And then factoring cosecant squared theta minus 1 is cosecant theta plus 1 times cosecant theta minus 1. All right, so some strategies for verifying trig identities. First, try to rewrite the other functions in terms of sine and or cosine using your quotient identities and reciprocal identities. This will help to narrow it down from many trig functions to, at most, only 2. Also, try working on both sides of the equation at the same time, or you can work on just one side. The idea is that you get the two sides equal to the same thing, so you've shown that they're equal to each other. Try working on the more complicated side of the identity. I know typically if we see something that looks scary, we want to avoid it, but having more information there, a more complicated expression, actually gives you more to start with and more to work with. So it might actually be advantageous to start with a more complicated side. Use reciprocal and quotient identities to write complex fractions we can simplify. We got our least common tiny denominator method for that. Before you add or subtract any rational expressions, make sure you obtain common denominators. So again, to get common denominators, multiply the numerator and denominator of one fraction by the denominator of the other, and vice versa. And then try Pythagorean identities, especially if you see or find trig functions raised to a power. So see what you can do with any Pythagorean identities there. All right, so example 6, we'll split this example because there's a few, A through, I think it's F, I don't remember. So we're going to verify that tangent of theta is the sine of theta times the secant of theta. So as far as where to start, I am counting 1, 2, 3 different trig functions. So let's rewrite each of them using sines and cosines. So we know tangent is sine over cosine. Sine is, well, sine, we don't have to change that. And secant is 1 over cosine. So we have sine of theta over cosine theta equals sine of theta times 1 over cosine of theta. Then just multiply the expressions on the right. Sine of theta times 1 over cosine of theta gives us sine of theta over cosine theta. So we've shown that each of these two sides, although they look different from the way they're written, they're actually the exact same expression. They're both equal to tangent or sine times secant, or they're both equal to sine of theta over cosine theta. So a couple strategies here, converting everything to sine and cosine, and working with both sides of the equation at the same time to show that they equal the same thing. So if this tangent of theta equals sine over cosine and sine times secant equals sine over cosine, two expressions equal to the same expression must equal each other. So it's basically the transitive property. All right, part B, secant theta minus tangent theta times secant theta plus tangent theta equals 1. So we've seen this already with the alternate form for our 1 plus tangent squared equals secant squared, but we can multiply this out. So we take secant of theta times this secant plus tangent, and then we have negative tangent theta times secant plus tangent as well. So we just multiply it all out. When we do that, secant times secant is secant squared. Secant times tangent is secant times tangent. Negative tangent times secant is negative secant tangent. And then negative tangent times tangent is negative tangent squared. And notice that these will cancel each other out. So we got secant squared minus tangent squared, which we know from our alternate form, the secant squared minus tangent squared does equal 1. So just a little verification of factoring those difference of squares. All right, so that about does it for this video. Thanks for watching. I'll see